Okay, so there were a couple questions regarding radicals and also resonance structures for radicals. So let's start with the issue of what is a radical in organic chemistry. Um, the basic answer to that is that it is any carbon that has an unpaired electron on it, so it has an odd number of electrons. So let's take, for instance, methane, and let me break one of the carbon-hydrogen bonds and give one electron to carbon and one electron to the hydrogen. So we know from the Lewis dot structure that we brought the hydrogen atom and the carbon with its unpaired electron, we paired those up. So in other words, we had something that looks like this, and then when each of those two unpaired electrons, when they shared, the carbon shared it with the hydrogen, we formed the carbon-carbon bond. Now, we're going to use arrows throughout the year to indicate the movement of an electron. And if you just have one electron, you use what's called a fishhook arrow. And so the carbon would share its electron with hydrogen, and hydrogen would share its electron with the carbon. And in doing so, it's going to form that carbon-hydrogen bond. So if I take my carbon-hydrogen bond and I break it apart, the way I would write that is I would simply write a fishhook to that hydrogen and a fishhook to that hydrogen. This means the movement of one electron, and the arrow shows where the electron is moving from to where it's moving to. So at the end of this, I would have a carbon with its unpaired electron and a hydrogen with its unpaired electron. Now, the hydrogen with the unpaired electron is nothing more than a hydrogen atom. The carbon with the unpaired electron I would call a radical. Does it have a charge? No, because this carbon it owns one here, and one here, and then it owns that one outright. So it came with 4 electrons, it has 4 electrons, therefore there's no charge on that carbon. But there is an unpaired electron, an odd number of electrons, and that's what makes that carbon a radical. Radicals are obviously unstable because they don't obey the octet rule. Odd numbers can't obey the octet rule, and so that would be what a carbon radical looks like. Now, in the textbook, when they talked about resonance structures, one of the ways we can look at that is a resonance structure for a radical is, let's say we had a species that looks like this. And I'm going to write the full-blown Lewis dot structure at this point in the semester. So let's say that, for instance, I have this molecule with the carbon-carbon double bond. Now, let's lose a hydrogen atom from this. So in other words, let me break this carbon-hydrogen bond, bring one electron, give one electron to the hydrogen, give the other electron to the carbon, using, again, my fishhook arrows indicating the movement of one electron. And so what that's going to do is that's going to then give me this carbon that now is a radical. It has an unpaired electron. Again, it's neutral. There's no formal charge on it. But now what I could do is now I could write the resonance structure for this, and it will show 3 fishhook arrows. So let's, and I'm going to break this down because this is the first time we would do this. Let's say that I broke the carbon-carbon double bond. I'll take that and I'll erase it, and I'll replace it with the 2 electrons that are in that bond. for me to write the resonance structure for this, what I could do is I could take this unpaired electron and now pair it up with that unpaired electron to now form a carbon-carbon double bond over on the right-hand side, and that would leave the carbon on the left-hand side with an unpaired electron. And so in this case, we would write this. We would write the third fishhook showing the unpaired electron going to that carbon. So there's two resonance structures for this. Now I showed you this by breaking the carbon-carbon double bond. Let me show you how we would really write this. So what we would have is we would have this as our first radical, and the resonance structures, remember, have double-headed arrows. And so if I form the second resonance structure, it's going to look like this. And so the way I would show the fishhook arrows to get from the left structure to the right structure is like this. I'm going to take one electron from this double bond, and I'm going to pair it up with that unpaired electron, and then I'm going to take the other unpaired electron in the double bond and move it to that carbon. So that lets me draw the resonance structure on the right. If I wanted to, and I forgot my electron there, if I wanted to go from right to left, I would simply say, let's break this bond. Let's pair up that unpaired electron with the carbon, with the unpaired electron on the left-hand side, and now move the unpaired electron that's remaining in the double bond to the carbon. So these two structures would be resonance structures. They would actually have the same energies because they're basically, they have a double bond and an unpaired electron. Okay, so that would be why we have the three fishhook electrons showing the resonance structures that we could get for a radical. And we're going to do this more towards the end of the semester in terms of writing these resonance structures.